Hi guys, today we are going to speak about homogeneous function. Okay, how to solve first degree first order differential equation. Okay, when the function is homogeneous. Okay, so first we have to understand what is homogeneous function. Homogeneous function is a function that can be written in this form, whether in this form, or in this form. Okay. So then we call this function as homogeneous function. So whenever we have an homogeneous function, okay, suppose we have a differential equation like this. Okay, this is a differential equation, first degree first order differential equation. So this differential equation, now that we know that this mxy and upon nxy is a homogeneous function, okay, if this function is homogeneous. What we mean by homogeneous? So they are homogeneous. They can be represented if m of x and y upon nxy can be represented in this form or in this form, in one of these form down upstairs. So we can say that this function is homogeneous. Okay. So before starting solving an exercise, okay, you have just to be, as I used to say, you have to be aware which kind of function it is, okay, in which form it is presented, so that it will be easier to us to understand and to apply any method we feel like. Okay, now, okay, let us suppose we have here this equation. Okay, suppose we have here this equation, x squared plus y squared, okay, plus y squared dx plus minus 2xy dy equal to 0. So the first thing we have to do, okay, is that an homogeneous function? So by looking, you can see that this is an homogeneous function. Why? If you put here x in the place of x, if you put here dx in the place of y, dy, you will see this will be t square y square, t square x square, t square y square, dx minus 2. This will be xt and yt. So t square also will be there. So you get common factor t. Okay, t square is common factor. So it means that if t square is common factor will be there, these guys will remain the same. X and y will remain the same, and x squared plus y squared will remain the same. This is what we mean by that. Okay? Okay, so I hope you can understand this clearly, because this is very important. First, you have to check whether the function is homogeneous or not. Okay? So in this case, how to check whether the function is homogeneous or not? This exercise is in the form of m of xy dx minus n of xy dy equal to 0. All right, so when this is homogeneous, it is homogeneous, just see in this case. Okay, we just this is plus, sorry. Okay, so when this guy is homogeneous, it is homogeneous when, okay, then you can come here and separate them. Okay, you can separate them, send this guy there, this will be dy, and here m of xy, okay, n of xy, okay, equal to minus m of xy dx. You see now? Okay, see, this is true. If this is true, what we are going to do, send this dx here, it will be dy upon dx, and ny x down, it will be minus m xy upon n xy. Is that okay? So it says that if f of x, this m xy upon n xy is what? Is your f of x function, f of xy function. If f of xy is, okay, f of xy, if I divide these two and I can, and this f m by n x of xy, that is equal to minus f of xy, okay, minus f of xy. If this f of xy, that is the ratio between them, okay, is homogeneous, I mean can be represented in this form, in one of this form, then I can say that this one is an homogeneous function, and then we will apply the particular way to solve this homogeneous function. Okay, yeah, let us see. Now, is that true? Let us solve for this one. How to solve? That's the question. See, suppose here we have this one, this exercise, x squared plus y squared, okay, plus y squared dx minus 2xy dy is equal to 0. Yeah, is that true? Nice. I know, okay, that this expression here, okay, I can reduce in this way. Dy upon dx will be equal to minus what? This guy go there, so this will be what? So just send this one outstairs here. Just this guy is positive, go there negative. Okay, yeah, go there negative. So negative will be positive. So in the end, you will end with this expression: x squared y squared, and here 2xy. Okay, you will end with this expression at all. Okay, just do this basic calculation. Now, what's the next step? The next step is just to see whether this function can be is a homogeneous function or not. Just by seeing, you can see that this is a homogeneous function. Okay, this is an homogeneous function. Why? It's very simple. Why? If you just here, okay, here, f of x, do this one, dy will be equal to what? This is the f of x, t, xy. This will be what? Tx square plus t square y square all upon 2 tx and ty. Okay? So if you see this expression over here, this will be what? This will be t square common, x square plus y square. Okay? And here you'll get 2xy and t square. Okay, now let us see what you will end with. This will be t square will be 0, will be like t square upon t square is 1, so it means that t to the power 0, it's like t raised to 0, and here you will get x square plus y square upon 2xy. See, you could write the function tx and ty. You could write the function, okay, this function, okay, like this, okay. So it means that you have just to compare with the function, this one. Compare just this, okay, with the, because I said that an homogeneous function can be written in this way, okay, in this way. We will just compare. And this is x squared plus y squared upon 2xy. Now see, what is the function? Okay, see, sorry, here it is f of xy, but no problem. Okay, this is f of xt, yt equal to t the power n, and f of x, y. See, if you compare, you'll see that this expression here is equal to this one. Okay, this is your f of xy, and this is your t raised to n, and here raised to 0. So that means that this function is homogeneous. So if this is homogeneous, now we can just solve, I can just solve. But see, these are these steps that I'm taking is just to explain, okay? Because the first video I'm going to upload for any method here, the first video is just to explain, okay, to make you understanding. But the next, when we are starting the solution, solving exercise, okay, that it's not that much pedagogical video. Those videos will be just to solve exercise, solve problems. Now we can just say, okay, if this is, now we know that what is a homogeneous function. Now we know how to check whether a function is homogeneous or not. Now let us solve. Okay, if x squared plus y squared and this is dy minus 2xy dy equal to 0. How to solve this homogeneous function? That's the question. Okay, how to solve them. So to solve this homogeneous function, now that you could just write in this form, okay, we ended in this dx, we said this is equal to x squared y squared upon 2xy. Now it's true. So what else we have to do? So the next step is, if this is homogeneous, as we have proved, we have just to do the substitution, y equal to vx. Okay, make y equal to vx. Make y equal to vx. So what does it mean? So now apply differentiation, okay, with respect to x, both sides. So this is a product, as you can see. This will be dv dx times x plus v dx upon dx. Okay, so what we are going to have here, dy upon dx will be equal to x dv upon dx plus v, because dx with respect to x will be 1. So now we do this substitution. Okay, I will call this double star and I will call this star. Okay, and let us call this expression here as 1. Okay, what we are going to do, okay, the next step is just we are going to introduce star and double star in 1. Okay, let us write this one like this. Okay, here we have dy dx is equal to x squared plus y squared upon 2xy. Now we know that dy upon dx is equal to x dv upon dx plus v, and we know that vx is equal to y. Nice. Just substitute this. Okay, if I substitute double star in 1, okay, what we are going to have, just substitute this expression and this expression in this main layer expression. Okay, substitution. So what you are going to have, you have x dv upon dx plus v is equal, this is dy dx is equal to this expression. So where you find x, it will remain x squared, but where you find y, you will change by vx squared, and here you will get 2vx, and here you will get x. Okay, now that we are fine, this will be dv dx plus v, and here it will be x squared common, because here with 1 plus v squared. Okay, and here you got 2v and time x squared. Okay, so as you can see, x squared and x squared common will be just simplified. Okay, you can just simplify them. Okay, that's okay, you can just simplify them. What's the next step then? Just solve for this. This will be x dv dx plus v equal to 1 plus v squared upon 2v. Is that okay? Yes, it's fine. Till now it's fine. So what's the next step? The next step is just to put all together. This will be x dv and dx, okay, equal to, go there, 1 plus v squared upon 2v minus v, okay, minus v. So as you got this one, so yeah, you got this one, this exercise. So just here you have just to do what, if you feel like, okay, if you feel like, you can find the common denominator, or you can just leave it as it is, okay, because here you got 1 upon 2v plus, okay, this dividing this will be v upon 2 minus v. Okay, and here it is x dv upon dx. So in a nutshell, whenever we have how can I say homogeneous function, we have just to apply, okay, just apply the substitution, and just apply this differentiation, and the next step is just to substitute them. So you will end with an expression that can be solved by applying separable method, okay, separable method. So if you can see here, everything is lying on v. Okay, so the function of v will be gathered, will be together with the function, with the differentiation of v, and the function of x will be together with the differentiation of x. So you can send this guy here. It will be x dv equal to 1 upon 2v plus v. This, you can find the common denominator in this one. Okay, this will be minus. Okay, it will be minus v upon 2. Okay, and here dx, and this guy go here and this guy go there. So just apply separable method. This guy can come here just down. This one can come here down. Okay, 1 upon 2v minus v upon 2. Okay, minus v upon 2 equal to dx upon x. Okay, it's up on you. Then here you can just find the common denominator and just solve this equation. Okay, if you find the common denominator here, what you're going to have here, you have 2, and here you have 2v squared. So this will be dv upon 2 minus 2v squared, or upon 2. Okay, here it's the same, all upon 2v. Okay, so you can cancel out all these 2 and you are finished, you are done. Okay, dx upon x. Now what you have to do, you have just to simplify. Even if you simplify these 2 to 2, you will finish, or you will end with an expression like this. Okay, you will get this one. Just we are starting from here. This will be dv or v dv. Okay, because this down will go up, and this one will remain the same. 1 minus v squared equal to dx upon x. Okay, dx upon x. Now that you have this one, so yeah, integrate this both sides. If you integrate this both sides, what you're going to have, you're going to have this expression up here. So what does it mean? This guy, if I differentiate this guy, I will get v, but the only problem is that I'll get minus 2v. So what you have to do, just add minus 2 here and take minus 2. So you'll get 1 by 2, negative out, and this one can be written in this form, 1 minus v squared, and here 1 minus v squared. Okay, equal to integration of this dx upon x. Okay, yeah, now that you have this one, this will be minus 1 by 2. Okay, minus 1 by 2. This integration, we know it is ln of 1 minus v squared equal to ln of x plus c. Okay, minus 1 by 2, we know what else do we have to do? We know that this guy can come here. Okay, this one can come here. You can just call this one here and this come here. It's up on you. Okay, it's up on you. So it's up on you. So I will call this one, just apply some rules of logarithm if you feel like. But even if you let this like this one, it's fine. Then just substitute what is v and that's fine. Okay, but I will just try to solve this. Okay, then this minus 2, and you can come here. This is 1 by 2. Negative. So what is the next expression then? So the next expression then, you can come this one to come here, ln of x equal to c. This will be what? This will be the same as a right ln. Okay, this will be this is minus, so it means that this guy will be down. Okay, and this will be root, and this is minus. Okay, also will be down. This will be 1 upon, okay, this 1 by 2 is root of 1 minus v square. Okay, minus v square, and this is minus ln of x equal to c. Then here you can just play. This will be this. What we are going to have, this will be 1 upon x root of 1 minus v square equal to c. Now from here, just apply Euler and Euler, Euler to the power x, and here ln Euler to the power this 1 upon x root of 1 minus v square. Okay, this one will be 1 upon x root of 1 minus v square equal to c. So Euler is a constant, so constant to the power constant, this will be also constant. Now just substitute. We say that y is equal to vx. What is v now? So v will be y by x. Okay, then substitute there. You will get 1 upon x root of 1 minus y by x square is equal to c. Okay, if you feel like you can do also some simplifications, okay, you can simplify this expression here. Okay, you have x root of 1 minus y upon x square, okay, equal to c. Here you have this one, so if you find the common denominator here, you get 1 upon x, and here you'll get x square minus y square all upon x square. So yeah, is equal to c. If you put this one out inside or this one outside, this x and this x will be cancelled out. So you'll get 1 upon root of x square minus y square all upon x and time x. Yeah, just like this. And this will be c, so this will be cancelled out, this and this will be cancelled out then. So in the end you will finish like this. This will be x squared minus y squared equal to c. Okay, so this is the common solution for this equation. Okay, the equation or the differential equation is x squared plus y squared, okay, dx minus 2xy dy equal to 0. So this is the general solution for this case. Okay, general solution. Okay, hope you may enjoy this. Thank you. And in the next video we are going to start many different we are going to start solving different exercise. Okay, like many different exercise. Okay, like yeah, even for those non-homogeneous, reducible to homogeneous function and things like that. Thank you. Enjoy your time. So hope you can understand that this could be helpful for you. Next video we see you.